Hey folks, welcome to today's tutorial looking at the skewness and outliers in the data section for the General 2 syllabus. So I thought we'll start off by looking at some of the different types of shapes of graphs within data graphs. So we've got here the smoothness, so data has no breaks or jagged sections. It's just nice and smooth, looks like a bit like an exponential graph. Symmetrical graph, so data is symmetrical and balanced about the center, so the left hand side is the same as the right hand side. Very important later on, that one in sort of year 12. Unimodal, so modal we know to be the most common, which is going to be another part of our data and statistics section. But unimodal means it only has one mode or a peak point. And you're thinking back to like a dot graph where you might have dots here, and you might have one here, and then you have a few up there, another one. You can see the shape of the graph there. It's unimodal because there's only one mode. Bimodal means that you might have two modes at the same height, so it goes down, back up again. And it's sort of bimodal 2 points, and multimodal means it has many peaks or modes. So when we come into looking at skewness, the skewness looks to see whether or not the data is sitting on one side of the graph. If it's right in the middle, it's that symmetrical sort of look, like here, So it's you can see that it's nice and symmetrical, that most of the scores are around about the middle part, and then gradually get smaller and higher. And that's what we like to have. Often we refer to that as the bell curve. It's what we like to sort of see. Mostly things in the middle, and then a few things get smaller and smaller as you go to higher and lower values. So the next two are positive and negative skewed. And this can often cause a few problems, because often people think if it's positively skewed, it's skewed to the right hand side, because often we associate the right hand side of things to be positive. But it's actually a little bit different. Data is more on the left side, the long tail is on the right side, or the positive side. So there are a few different ways to think about positive data. The tail is on the right hand side, to like the positive side, as you can see there. The tail is on the negative side. The other way I like to look at it, as in a group of scores. Let's say you got scores on an exam. Now, if everyone did really poorly on the exam, or should I say, not many people scored the highest marks, it means that the results are going to be quite spread out, and they're going to be quite useful. I would call that to be a positively skewed results, because I don't want everyone getting 100%, because then it's sort of no point to me. So if I think about everyone getting 100%, how can I distinguish between the different people? Therefore, that's a negative graph. So I look at it this way, that if it sits mostly to the right-hand side, it means everyone did really well, and that's a negative test for me, because it's pretty useless. But if everyone, if it's spread out, that means not many people did well at all, so everything's sort of skewed to the left-hand side. Okay, that for me is positively skewed. But look, it's a little bit tough sometimes to think. Often it's the opposite of what you think it's going to be. But whatever way you feel, make sure you know if it's to the left-hand side, it's positive. If it's to the right-hand side, then it's going to be negative. The next section we're going to look at as well is the outlier section. Now, we all know what an outlier is. It's that score that lies away from the rest of them. But at what point does that score become an outlier? For example, if I had things like this, it's not really a number. Let me redo that one. I don't even know what I was trying to do. I think I was trying to do like halfway between a 2 and a 3. 1, 2, 3, 5, 100. Now, obviously, looking at those numbers there, 100 is going to be an outlier because it's nowhere near 1, 2, 3, and 5. What if I had 1, 2, 3, 5, and 10? Now, is 10 an outlier? Okay, certainly it's nowhere near 1, 2, 3, and 5. They're quite close together. There's a big gap. So at what point does that become an outlier? So on your exam papers, you will have the formula sheet. On the formula sheet, you have this formula that I've added here in the page. Hopefully you've used this one before. So it says the outliers, scores that are less than QL minus 1.5 times IQR, or scores more than QU plus 1.5 times IQR, which basically means if you find, what the interquartile range is? If we times that by 1.5, and add it on and take it off the lower and upper quartile, if it is past that range, then we call that being an outlier. So we're going to use an example to show what we mean. First of all, I'm going to put these in order from smallest to biggest. 5, we've got a 6 there, 2 more 6s, we've got 2 8s, we've got an 11, a 16, and a 34. Okay, so why have I done that? Well, we want to find the median, so then we can find the lower quartile and the upper quartile. So find the median, 1, 2, 3, 1, 2, 3, 1, 2, 1. So my median, which is Q2, is 8. 1, 2, 1, 2, 6 is my Q1. And we've got 1, 2, now 11 and 16, so that's going to be 27. Half of 27 is going to be 13.5 is Q3. Okay, and then my highest and lowest, if I needed it there, I could have it, but it doesn't really matter. So first of all, let's find IQR, which equals 13.5 subtract 6. Okay, and 13.5 subtract 6 is going to give me 7.5, I think. And I'm going to times that by 1.5 because that's what it says up here. 1.5 times the IQR. So times that by 1.5, we get 11.25. So in order for my data to have an outlier, we need to add 11.25 onto 13.5 and take 11.25 away from 6. So if I do the first one, 6 take away 11.25, which to be honest, I probably don't really need to do so much because you can see there are going to be no negative scores, but I'm going to put it on there. And if I added on 11.25 to the 13.5, we're going to come up with 24.75. So basically, in order for my score to have an outlier, the score needs to be less than negative 5.24, or it needs to be greater than 24.75. So I look at my scores. We have one score, which is 34, which is greater than 24.7. So it is an outlier for that set of numbers. Let's just have a quick look at this one here. Was 10 an outlier? Let's have a quick look. 1, 2, 1, 2. 3 is my Q2. 1.5 is my Q1. 7.5, if I look at things, is going to be my Q3. Now, my interquartile range is 7.5 take away 1.5, which is going to be 6, times that by 1.5, so 6 times 1.5, and that's going to be 9. And I'm going to do 1.5 take away 9. Well, that doesn't really work, but I'm going to do 7.5 plus 9, which is going to be 16.5. Therefore, 10 is not an outlier. So you can sort of see where I'm going with those types of questions. Look, I'm not going to do part B there. You can do that yourself later on. But you can see each time the big key things are that I need to know what my Q1, 2, and 3s are. I need to find my interquartile range and times it by 1.5. Then I need to add it on and take it away from my Q1 and Q3. So a lot of time you don't even need to take it away from Q1 because your scores aren't going to be negative. But certainly, if it's a possibility, do it. Otherwise, yeah, it's pretty straightforward. All right. Last thing, we're going to look at an extended type of question, which includes quite a lot of stuff that we've done so far. High school students were surveyed, and the results of the two samples are shown below, sample A and sample B. Part A says, my apologies there, Part A says, for sample A, correct to one decimal place, find the median, the mean, the mode, and the standard deviation. Okay, so It's going to be quite a long-winded question. I'm just looking down the other questions. I have to draw a frequency histogram and no cumulative, so that's okay. What I'm going to do is I'm going to draw up one of these frequency tables. I'm going to put my score there, my frequency there, and I'm also going to put my FX, my CF column. Now, I'm not probably going to do FX because I can use my calculator to find the mean for this. This is more for the median. So I've got 1, 2, 3, 4, 5, 6, and 7. Okay, so my frequency is 3, 5, 8, 9, 8, 5, and 3. So my cumulative frequency, remember, we add on the first frequency and then add the next one. So 3 plus 5 is 8, so 16, 25. We're going to do 33, 38, and then 41. Okay, remembering that if I add up these numbers here, that will equal 41 as well. And if I'm trying to find the median for that first one, okay, my median is my middle number. It's quite hard because it's in a table of values. But if I look here, I've got 41 numbers, which means I've got 20 numbers here. I've got another number in the middle, that's the 21st number. Then I've got another 20 numbers on the right-hand side. Therefore, my middle number here is the 21st number in the set of data. So basically, all I'm looking for is where that 21st number lies. Here's my first three numbers. And this is the 4th to the 8th number, 9th to the 16th, 17th to the 25th, which means that is where my median or my 21st number lies. Therefore, my answer is going to be 4. Okay, quite complicated, I know, but you've got to give it a crack. Now, for the next part of the question, for the mean and particularly for the mode, so the standard deviation, I'm going to be using my calculator. And just quickly for the mode's really easy. I'm just going to look here. The mode here is going to be 4 also. It's the most common. But so remember, in your calculator, you can chuck it into your statistics mode, get your double graph, so your 2 columns with your frequency column, enter the X and Y values in, then go through by doing your one variable data, and then pressing a 2 for the mean, which in this case, the mean is going to be 4, so I can write that in, and then pressing, going back, doing those same sort of options, pressing 3 for the population standard deviation, and that will give me 1.64 to 2 decimal places. But again, that's using your calculator by entering that data therein using your statistics mode on the Casio calculator. I'm not going to bother doing that again for part B. It's just going to be the same sort of process. For part C, it says construct a frequency histogram for A. Okay, so I'm just going to do this briefly. A very small one. It's not going to be accurate. Yours should be. So if I'm going to do a frequency histogram, I'm going to put my scores on the bottom. I'm just going to move that up just a touch, guys. So I've got 1, 2, 3, 4, 5, 6, and 7, making sure they're all the way apart and starting away from 0. Remember, we're doing frequency, okay, not cumulative frequency. So frequency is going to be from 3 up to 9. So we can do 1, 2, 3, 4, 5, 6, 7, 8, 9. And again, you do this, a nice big spaced out graph would be the best for you guys. And then I need to put on my information. So for 1, we're going up to 3. Then for 2, we're going up to 5. For 3, we're going up to 8. For 4, we're going up to 9. 5, we're going up down to 8. For 6, we're going to 5. And for 7, we're going to 3. Okay. You can notice there with the frequency histogram, they're all up and down. If it's a cumulative frequency or an ogive, then you'd be they'll all be going higher and higher. Now it says a frequency histogram. It hasn't asked for the polygon. However, I am going to draw the polygon on there just in case, not just in case, but so you can see. If I was asked for the polygon, okay, that's what I'd be drawing, but it didn't ask me that, so I'm going to take that away. Okay, so that was part C. Just making sure you put score on the bottom, frequency there, and you might put a little name for it, which might be high school students in a school. Okay. E says describe the symmetry and modality of sample A and sample B. Well, I'm just going to be doing sample A. So the modality, I'd say this is unimodal because there is one peak. If I sort of do this in terms of, oops, that's not really a nice line here, like that sort of graph, you can sort of see it goes up to one peak. So it'd be unimodal, that'd be E. And for F, it says describe the skewness. Well, that is definitely symmetrical, isn't it? Symmetrical. I think it's one M, by the way, so apologies. So it is symmetrical. Actually, no, it is two M's. So again, that will be slightly different for sample B, but you kind of get the drift of that. There's a lot in there, okay, particularly with the symmetry and the unimodal and bimodal and multimodal, all those sort of things, and particularly being able to use your calculator effectively. So I hope this kind of made a bit of sense to you folks. Keep trying, keep practicing. Any questions, please send them through. Have an awesome day.